Hello, I am Dina Graves-Portman, and I am here today with Dave Stanke. We are both developer relations engineers with Google Cloud, and we are here today to talk about the 4 keys and how you can use it to measure DevOps success. Okay, so these are going to be our key points, our key takeaways. This is what we want you to end this talk knowing, thinking, etc. First of all, software development operations can be measured, and we will argue possibly should be measured. Secondly, the 4 key metrics are indicative of team and organizational performance. Thirdly, you can instrument your systems to gain continuous insights and use that to drive continuous improvement. And last of all, maybe most importantly of all, you can get started with our open source project, and you can find that at bit.ly/DORA-4keys. Okay, I'm going to hand it over to Dave, who is going to give us some background on the 4 key metrics and DORA and, why we should care.
So let's start with definitions. First off, what is DevOps? Well, DevOps actually doesn't have a definition by design, but it's worth putting some words around it to get a sense for what we mean when we talk about DevOps. And Google Cloud offers one definition, and this is it. It's an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. But a picture is worth 1,000 words. I like to define DevOps this way. DevOps is when we apply communication and automation to achieve velocity and reliability, all in service of happy users. Now, one of the teams within Google Cloud is called DORA, DevOps Research and Assessment. This is an organization that for the better part of a decade has been studying software development teams across companies of all sizes in all industries and around the world. And they've applied rigorous statistical methods to determine what makes good software teams succeed. The outcome of all of their research has been developed into this model, a predictive model that says certain capabilities, tools and practices and ways of working are predictive of outcomes. Outcomes like organizational performance, less rework, less burnout, things that are really valuable for companies and for humans. And they've stitched it together into this predictive model. This is actually a small subset of the model. You can find the entire thing at bit.ly/DORA-BFD, that's big friendly diagram. But we're going to focus in this talk about software delivery and operations and how we measure that. So what we found through our research program is that it boils down to 4 key metrics. These 4 key metrics indicate the overall success of a software delivery team and how much they're able to deliver those outcomes that we are valuing. 2 metrics for speed and 2 metrics for stability. Let's take a look. The first speed metric is deployment frequency. How often are releases going to production? And is that measured in terms of releases per year or quarter, or as much as weekly or even multiple times per day? The second speed metric is lead time. How long does it take from a commit from the time it lands into your VCS to when it's deployed into production and a user can use it? What's that lead time? Then we have 2 stability metrics. The first is the change fail rate. So when we make a deployment, what's the rate at which it fails and needs remediation because it's caused user-facing impact? And finally, time to restore. Of those failures that happen, how long does it take to restore service to the point where customers can use the service again? Now, a pleasant surprise when we look at the metrics is that velocity and stability are not opposing forces. We looked at high-performing teams, or what we call elite performers, the very peak of the software delivery performance teams, versus the low performers. And what we find is there is a statistically significant difference, and a big one. The elite performers are performing at 200 times more frequent code deployments, 100 times less time from commit to deploy. The code is spending less time in the pipeline. And as they deploy, the deployments are 7 times lower, 7 times less likely to fail. And when they do have a failure, they're remediating it 2,600 times faster. So what we can see here is these elite teams are outperforming the low-performing teams on velocity and stability. These are not opposing forces. They're actually excelling at speed and reliability. Now that can seem counterintuitive, right? We're used to the idea that if you go fast, you're going to break things. But if we look at the predictive model that DORA has developed, we can start to see some of the mechanisms here and understand how these are complementary and in fact reinforcing. So what we notice when we dig into the model is that adoption of essential capabilities and practices predicts both velocity and stability. One of the mechanisms that underlies this is about batch sizes. The bigger a batch is and the longer it sits in the pipeline, the greater the chance it will cause an outage. We want to avoid deployment debt. It's important to keep a continuous linear stream of code into production. By developing these key capabilities, we can achieve outcomes like greater availability for our customers, better commercial performance for our businesses, and increased job satisfaction for ourselves. Of course, the best way to improve is to have objective, consistent measures of our progress. Which brings us back to these 4 key metrics. When we benchmark our team specifically against these measures of software delivery, we can discover what's holding us back and focus on efforts on improving where it's needed most. So exactly how do we measure these signals? Dina's going to tell us how we've implemented this in the 4 Keys project.
Thank you, Dave. Okay, so high level, there are 2 ways that we can come to these metrics. The first is through surveys data, and all of the DORA research was done through surveys, which is great. But we're interested in systems data because when we look at surveys, on one hand, they're really quick and easy to use. You can fill out the survey and instantly have a check on how you're performing compared to your industry. But they are susceptible to bias. They're difficult to measure over time, and they're not automatic. So we're more interested in using systems data because we can help alleviate some of the bias. For instance, if you recently had a big outage and it was flashed all over the news, you might have this like outsized understanding of what your change failure rate is. Whereas if we look at systems data, we can see that tracking over time, our rate is X, and then that won't be influenced by our recency bias. Secondly, it is easier to measure over time. We have really, really bad memories, just as humans, like everybody has a bad memory. And when we look back at the past, we forget a lot of things that happened. And so when we're thinking about, are we performing better now than we were a year ago? Maybe we've adopted this new change management system. Maybe, there's this new VP who's moved us all to cloud and we're using containers, et cetera, et cetera. We have this like feeling that we're moving faster, or maybe we have a feeling that we're not moving faster. It's really difficult to know that without having systems data to actually reflect that over time. Thirdly, systems data exposes the bottlenecks, which is something that it's really hard to get to from surveys data. Because if you have all of the data, when, for instance, the first commit happened, and then it goes into code review, and then it's merged or submitted, and then it enters into your deployment pipeline. Well, you can see for the entirety of your pipeline, like where this code is sitting for the longest point of time, so you can understand like where your bottlenecks are. And last of all, it really helps quantify experimental success. So if you are doing an experiment, maybe you are using some kind of new architecture for your application, and you have a hypothesis that this is going to help improve your deployment frequency. If you have the systems data, you can see, sometimes pretty early, like week to week, that your deployment frequency is trending in one direction or another, which would be something that would be really difficult to do with surveys, because if you were just constantly taking surveys, there's a thing, survey fatigue is a thing, and your response rate will drop off really quickly. But on the other hand, systems data, it's a little bit difficult to set up the collection of all this data, and then there are storage and engineering costs, which brings us to the 4 Keys project. we have created this open source project to help try to smooth out some of the friction and the work that it takes to set up the collection and calculation of these metrics from the various systems. Because the good news is that you have all the data that you need. The bad news is it's in like a dozen different systems. So when we were designing this open source project with the idea that it should be generic enough, abstract enough to work with any system that you happen to be using, our main challenge then is, well, how do we do that? Because developers use so many different kinds of tools and environments to do their work. So how do you capture all of them? And also, how do we account for unknown data sources, like sources that we don't know yet? Maybe I know that my team uses these 6 different tools to do incident management and version control and deployments and health checks and blah, 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 blah. But maybe your team uses 6 different tools. So it would be pretty easy for me to just, build the thing that works for my team and my team only. But how do you do it for everyone and everything? Things that I haven't even imagined yet. So the solution that we came up with was to create this generalized pipeline that takes in events via a webhook and ingests them into BigQuery. So that way, like the sources and the integrations that we already know about, we can pull in pretty easily, and then anything else can be extended by just adding another one of these workers and another like pub subtopic to map the data from this new source. And I always say, like, the best part about this project and the most value of this project is the data mapping and also the metrics calculations. So data mapping, it's a real challenge. It's an upfront cost. We've done that for a variety of sources, and the problem is that, like, even looking at the data mapping, we don't know precisely what your pipeline is or what your operation is, what you consider a successful deployment. So we're sending everything into this raw events table. So this should contain every event related to development, deployment, incident management. This is your DevOps log. It contains everything. When in doubt, it should be streamed into this table. And from there, downstream from there, we have these scheduled queries that read from the raw events table and derive these 3-dimensional tables: changes, deployments, and incidents. Because with these 3 entities, we can calculate our 4 key metrics, and that's all we need. Okay, so let's look at the metrics. To start with, we have deployment frequency, which is defined as how often an organization successfully releases into production. So this is probably the easiest of the metrics to collect and calculate because it requires only the one table. If you're using like a CI/CD system, you have all the data that you need. So you want to just stream that into the raw events table, and then we use it to calculate frequency. Now, one of the common mistakes that I see here is that people often confuse frequency with volume. And what we see is that people will have something like, let's say that you did 30 successful deployments in the past month. And they'll look at that and say, okay, so that is an average of 1 deployment a day. So we are deploying daily. Well, maybe yes, maybe no. That number doesn't actually tell you that. That is a volume. And really what we want to know is how many days, not how many deployments you had, but how many days had deployments over the past month. And using that, we can calculate and say that, generally there is at least 1 deployment a week. Generally, there's at least 1 deployment a month, daily, hourly, etc. And in that way, we calculate deployment frequency. So next, we have lead time to change. And this is the amount of time it takes a commit to get into production. So the lead time requires 2 important pieces of data. when the commit happened and when the deployment happened. This means that for every deployment, you have to maintain a list of all the changes included in the deployment. And if you are using CI/CD and you're like triggering a deployment every time, you know, a change is merged into your default branch, then this is like a super easy thing to calculate, because you have the SHA and you can map these back to the commits, pull out the timestamps, and then, you know, see this time was, you know, X, this time was Y, and now we know our median amount of time. So we join these tables together, and then we use it to calculate it. And our dashboard puts the lead time into buckets defined by the DORA research. So we'll have something like less than a day, less than a week, a month, a year. And in this case, less than a week is medium performance. So we show a yellow badge here. Next, we have the change fail rate, which is the percentage of deployments causing a failure in production. So with all of these metrics, actually, the thing that we're really concerned with is the experience that the user is having. So when we talk about deployments, you know, it was successful deployments. It's like it actually has to reach production, actually has to reach the users. In this case, this is a failure that reached production that the users are experiencing. If it failed to build and didn't even push to production, we don't care. That's not part of it. So this is a rate. Our denominator is the total number of the successful deployments, and our numerator is the total number of incidents. So to get this metric, we need to know the two things: how many deployments were attempted and how many resulted in failures in production. And the challenge here is that ideally we can have a direct association between these incidents and deployments. Like, we will know that there was a root cause and it was this deployment. Because when we're looking at these rates, since the deployments, since that's our denominator, when we're looking at the time span, we're basing it on the timestamps of the deployments. So if we're saying that our change failure rate for March was 10%, that is because 10% of the deployments in March caused incidents. Unfortunately, it is not always easy or possible to make this tight association, in which case then you have to fall back on something that's like, okay, we did 100 deployments in March and we had 10 incidents in March. We don't actually know. In that second scenario, we don't know that those are the deployments that caused the incidents, because they could have been a slow burn, like a result of something that happened in February. In which case, then, you know, whatever systems and processes we had in place in February were really the culprit here. And maybe they were already remediated by March. But in any case, ideally, you would have the root cause. You would be able to associate the incident with the deployment and get the change failure rate in that way. Okay, time to restore, which is how long it takes an organization to recover from a failure in production. So we don't care whether this is a rollback, a roll forward, a hot fix, whatever. The only thing we care about is that the user may have been experiencing a failure and then is not experiencing a failure. Once the user gets to the place where they're not experiencing the failure anymore, then we're considering that as restored. And to measure this, we're using the same two tables as we did before: incidents and deployments, joining them together. Again, ideally, we know when the deployment happened, because that is when the incident happened. And maybe you didn't detect it for a week. And that, you know, that's actually really useful information to know about. This shouldn't just be a measurement of how quickly you respond once an incident is filed. Like, you should know that there's something wrong happening in your system. And if it turns out that you have this incident just kind of sitting there like a slow burn for a month, then what that tells you is that maybe you need some more health checks. Maybe you need a smoother reporting system so that the users can bubble this information up to you. But fully acknowledge that information is sometimes difficult to get. So if you cannot make the tight association between incidents and deployments, then you fall back on when the incident was filed in your incident management system. But ideally, we can tightly couple these two pieces of information. We can join them together, and we can use that to calculate the median amount of time it takes to restore an incident. Okay, so here's a reminder on the infrastructure. We're doing all our work in all our various systems. All of those systems are sending those events to a webhook, which we call the event handler. The event handler is passing that information off, just passing that whole payload off to a pub sub topic that is associated with the source. So for instance, like you would have like a GitHub topic. And then that is pushing that message to a very tiny little application that does some very small ETL. It maps your fields. It's like, okay, this is the source, and we're going to put this in the source field, and this is the type of event it was, and then it takes the entire payload of the message and it just sticks that in the body, and then it pushes all that into our BigQuery table, our raw events table. And then we have these nightly scheduled queries that go through the raw table and create the dimensional tables that will tell us things like, this is when your incident started, this is when your incident finished, these are your deployments, these are all the changes with your deployments, and it gives you an entity for each of our changes, deployments, and incidents. And then that feeds into a dashboard. So I'm going to show you how, just a quick demo, how to set up the 4 Keys project. Okay. So we start running the setup script, and then we're creating a new project, and it's turning on some APIs, and then it asks us what version control system we're using. We're using GitHub. In this case, I'm going to use Tekton as my CI/CD system, and now it does all the good stuff. It's going to turn on APIs, it's going to set permissions, it's going to create secrets, it's building and deploying all our workers. It's going to create BigQuery tables. Now it's asking us if we want to create a separate new project to test deployments. I'm saying no because I have a project. I just want to use it. And I do want to generate mock data just to play with the dashboard a little bit. So it creates mock data, and then it schedules all our queries. And once this is finished, once the BigQuery job's complete, then we are going to walk through the Data Studio connector, which allows us to easily connect this 4 Keys data from our project and Data Studio. So it looks for the projects. There it is. We click connect. It gives you a list of all the fields. Okay. Click create report. And this pulls from a template that we made for the 4 Keys project. And there it is. And so we can see that we're kind of like a medium performer. We have some yellow badges, we have some green badges. Okay, we've got some mock data. And that's great, but I want real data. I want to connect this to a real live project. So let's start by just looking at our table. So this is our events raw table. And oh, there's a lot of data in here. Okay, it also says GitHub mock. So let's exclude GitHub mock because that's the mock data we just made. And now we see there are no results. So first thing we're going to do is we're going to integrate it with our version control system, and we are using GitHub. And so I'm going to need the URL for a webhook. And next I'm going to need the secret, which we created in the setup script. So there the secret is. and we want it JSON, put in the secret, and I want everything. I don't want just the push event. I want absolutely everything because I don't know what I'm going to need or when I'm going to need it. I just want everything. Okay, so now when I make an edit to this file, and I create a pull request, new branch, etc., then this is a series of events that have just happened. And we should see if everything's working. We should see this data in our BigQuery table. So we run it again, and huzzah! We have a pull request. Excellent. And we have a push event. We have all the data. You can see in the metadata right there, that's JSON. And that is just everything that GitHub is sending us, which is great. Okay, so I'm using, in this example, I'm using Tecton pipelines for my CI/CD. This is just a little hello world I've got set up here. And it is going to pull from a repo and then build it and deploy it Kubernetes. So just to show you that it is working, I am deploying. I'm going to make this little edit here. And when I commit it, then that will trigger the pipeline. So when I refresh, this will say, hello, Tecton trigger. Yay. Okay, I am deploying. Now, how do I get this deployment data into my 4-keys tables? Well, I am going to use, in the config for my Tecton pipelines, I am going to use the default cloud event sync, which is the way to send all of the cloud events to a webhook. Excellent. That's exactly what I want. It doesn't allow you to set headers or do anything like that. So we're just going to put the secret in as a param. Just pop it right in there. And we need to do this ultimately. We can't just have our webhook just open to everything on the internet, because we want to make sure that only authorized sources are sending it. Okay, so I've updated my pipeline. And now when I update this, in theory, this will build and deploy, and will also write to my 4-keys events raw. And there it is. There it is. These are all my Tecton events, and they have it at all these different phases of what the pipeline is doing, what the tasks are doing, and it's great because we have all of this information, and we have all of the JSON in the body there that we can use to really parse out what is and isn't a successful deployment for us. And look, I refreshed it, and it says hello 4-keys, so you can see that it works. And that is how we set up the 4-keys repo. Okay, so let's talk a little bit about the dashboard. This is the dashboard. In the middle, we have these badges that are very much pulled from the DORA research. And so they're bucketed in the way the DORA research is bucketed, and it's looking at the past quarter. And so it's zoomed out view. And this is the thing that is, when we're talking about these signals being predictive of all these business outcomes, these are the metrics right down the middle. But we have 4 other charts, as you can see. And the reason why these are in here is because people like early feedback. And this allows us to see our daily running log, so we can understand, how our performance is trending, perhaps before we have that zoomed out view and, it, trips from one bucket to another bucket. And so if I have some kind of experiment and I think it's going to reduce my lead time to change, then I can look at this dashboard, I can look at this chart in the corner here, and I can see whether or not it's trending up or down. If it were trending up, maybe I would say, oh, maybe we did this thing and it's not having good results, and then we can make sure we fix that before it causes too much trouble. And so we have that for all 4 of the metrics around the corner, but right down the middle are the actual 4 key metrics. Okay, just a little talk about, some anti-patterns. We really envision people using the dashboard to help identify where they need work in improvement, and then to conduct experiments against it. We do not want people to, start pitting teams against teams, because it's not very helpful. Your project may come with like a completely different set of tech debt than another team's project. And secondly, the data, it doesn't have a normal distribution. Each team's performance is just unique to whatever constraints they have. So the thing that is helpful is, a same team comparison over time. So when you're looking at the metrics and you're identifying where your bottlenecks are, and you have a theory, a hypothesis over what you need to do to improve your performance, then you can use the dashboard to say, yeah, my team started here, and now we're here. And that's great. The other thing we want to be careful about is the metric itself is not the goal. The metric is predictive of all these great outcomes, but it's a means to an end. It's a diagnostic tool. It's not the mission itself. Like, you don't exist just to have really good deployment frequency. You're probably trying to have good deployment frequency to deliver good products to your users. And so, the OKRs that you set, the goals that you set, should reflect your projects. It should reflect the experiments. It should be, we're going to try this new architecture, and once we get 90% of the project ported over to this new system, then that will be a success. Like, that is how you're measuring your success. If your hypothesis is wrong and that doesn't improve your deployment frequency, that is not a failure. That is a useful piece of information that you should then share with the rest of your company and organization, because that will save them time. Any well-conducted experiment is worth doing, and that is why, like, the success of it should be, on whether or not you executed it well, not on whether or not the metric improved. Okay, I'm done with that speech. How do you get started? How do you get involved? Well, I would like to invite you to try out our open source project, bit.ly/DORA-4keys. You clone the repo, run the setup script, and you can also read the blog post we wrote about it. And you can join us on Slack, where we have great conversations about the 4 key metrics. Stay tuned. If you have any questions, feel free to tweet at us or join us on Slack.